Evet, sevgili hocalarımız, öğrencilerimiz, hayırlı sabahlar diliyorum. 5. webinarla karşınızdayız. Genç İnşaat Mühendisleri Öğrenci Kulübümüzün düzenlediği, Gürol Bey sesinizi şansınız var mı? Evet, Genç İnşaat Mühendisleri Kulübü'nün düzenlediği webinarların dizisi olarak bu haftada Anfel Şeyma Hadidane kendisini tanıtacak ve güzel bir şekilde hazırladığı sunumunu bize sunacak. Sorusu olan sunumun sonunda sorabilir. Bu sunum bittikten sonra YouTube kanalımızdan, yani Genç İnşaat Mühendisliği Kulübü YouTube kanalımızdan yayınlanacak. Oradan da istenen arkadaşlar, yani sonra tekrardan dinleme şansları olacaktır. Evet Anfel, sen kendini tanıt ve sonra sunumunu başlayabilirsin.
Tamam. Günaydın herkese. Ben Enfer Şeyma Hadi'den. Girişim Üniversitesi doktora öğrenciyim. Bugün bir sunum hazırladım seminer için. Rehabilitasyon çelik konstrüksiyonunda, yani rehabilitasyon çok geniş bir konu ama özellikle ben çelik konstrüksiyonu seçtim.
Evet, bir araya gireceğim. Sen kendini bir eğitim şeyini anlatırsın. Lisansını, yüksek lisansını nerede okuduğunu bir kısa bilgi verirsen daha da yararlı olacağını düşünüyoruz.
Evet hocam. Lisans ve yüksek lisans Cizre'de aldım. Benim yüksek lisans özellikle çelik konstrüksiyon ve köprüler üzerinde çalıştım. Şimdi doktorada yani inşallah yani rüzgarın yükün altında çilek ve ya da özel binaların davranması nasıl oluyor? İşte yani şimdilik sadece yörük kod var. Yani en büyük, en geniş konu rüzgar yükün hakkında da bazı özel binalarda onun davranması yani çok büyük bir açıklama yok. İşte o yüzden biz onun üzerinde çalışmayı istiyoruz. Aerodinamik işte.
Evet, başarılar dilerim. Konumuza girebiliriz. Ekranınızı paylaşın ve oradan sunumunuzu devam edebilirsiniz.
Tamam hocam. Tamam. Görüyor musunuz? Böyle. İyi görüyorsunuz böyle.
Gözüküyor, evet. Şu an
Tamam.
gözüküyor. Sen ekranını büyüterek başlayıp evet devam edebilirsin.
Şimdi sunumum İngilizce ile olacak. Başlayacağım. In today's subject, I choose rehabilitation and steel construction. My table of content is gonna be like next. First, we're gonna start with a general introduction about rehabilitation and generally in steel construction. And then we're gonna get to the challenges faced during steel rehabilitation. After that, there's the advantages of steel rehabilitation over complete replacement, the methods used in steel rehabilitation, inspection and assessment before choosing a method, which is a really critical point in like rehabilitation. And then the potential risks associated with working on existing structures and like with steel or concrete. Like they both have really high risks. We're gonna talk a little bit about that. And then we're gonna get to the future and the new trends that can help with this kind of like researchers, which is rehabilitation. After that, I'm gonna conclude with a general conclusion. As an introduction, well, rehabilitation in steel construction is a vital process that involves like restoring, strengthening, and upgrading existing steel structures to ensure their continued safety, functionality, and also longevity. Steel structures, renewed for their strength, durability, and versatility, are widely used in various industries, including bridges, like buildings, industrial facilities, infrastructure projects. The aim of rehabilitation in steel construction is to restore the structural integrity and functionality of steel structures that have experienced deterioration or damage. So, by that, in such cases, rehabilitation techniques play a crucial role in existing. The field of steel structure rehabilitation is vital in maintaining the safety and reliability of longevity of our built environment. We're gonna first start with the challenges faced during steel rehabilitation. Well, during steel rehabilitation, several challenges may arise that require careful consideration and effective problem solving. These challenges include a lot of challenges, starting with structural assessment. So, structural assessment Structural assessment is like conducting a comprehensive and accurate assessment of the existing structure is crucial because it can be challenging because it may involve investing hidden or hard access areas, identifying the extent of any kind of buildings. Secondly, the compatibility of materials, like ensuring a good compatibility of new materials and systems with the existing steel structure can be challenging. So, the compatibility of a different steel grades coating and corrosion protection systems must be carefully evaluated to prevent potential issues such as galvanic corrosion or indicate bonding between new and existing components. Finding suitable materials that meet the structural performance requirements can be so complex. Third of all, structural integrity and safety. So, maintaining the structural integrity and ensuring the safety of the rehabilitation process are critical. Implementing safety measures and adhering relevant standards and regulations is essential. Limited access and space constraints. So, rehabilitation in existing steel structures often presents challenging related to limited access and confined spaces. So, accessing a certain areas for inspections, repairs, or strengthening may require specialized equipment. Time and cost constraint. As we all know, do working in rehabilitation can be a bit costing, especially with steel, which is one of the biggest problems facing the steel construction in general, not only for rehabilitation, but it's one of the challenges facing this kind of field. Complex engineering solutions, as we may all know, like doing a study to rehabilitate an already existing building is challenging for any engineer in particular because you have to really find the main problem and try fixing it. Also, documentation and AS build drawings. Usually, when we work, we have all the informations of the building, whether it was plans, drawings, everything. But sometimes when we do rehabilitation, it's usually for old buildings. So we don't really have that much of information. Sometimes the building is so old, so we are working from scratch and going blind because we really don't have any information about it. And now I'm gonna talk a little bit about the advantages of steel rehabilitation over complete replacements, because there's always the solution for complete replacement. But why do we choose rehabilitation over complete replacements? So steel rehabilitation offers several advantages over complete replacement, making it preferred choice. And some of the advantages are cost effectiveness. Well, as I said earlier, cost and financials in doing rehabilitation or a new building is a really challenging topic, and some might say it's the most important thing, but it is so important. So when working on an existing building can be less costly over doing a new building from scratch. Other components are still in good conditions. We don't have to replace them. So this reduces the overall construction cost by minimizing the need for new materials and labor-intensive demolition. Additionally, rehabilitation projects can be completed in a shorter time frames, resulting in further cost savings. So by that, we are gaining money and time at the same time. Minimal disruption. So, a complete replacement of steel structure typically involves significant disruption to ongoing operations, whether it's a building or a bridge or an industrial facility. Rehabilitation, on the other hand, can be executed in a phased manner, minimizing disruption to business activities or transportation, for example. Uh, for example, if you're working on an existing project, uh, you can continue working without sometimes having the work being suspended. Sustainability, which is a really important thing because rehabilitation in steel construction aligns with the principles of sustainability and environmental responsibility. In general, it allows for the reservation and utilization of existing resources, minimizing the consumption of new materials and reducing the construction waste. Additionally, rehabilitation projects can incorporate sustainable practices such as using recycled materials, implementing energy efficient systems, and optimizing the overall environmental performance of the structure. The retention of historical or architectural values. Well, sometimes when doing a rehabilitation, or actually in general, when working on a monumental structure that has a lot of meanings with history or personally, so we would prefer to rehabilitate it, not do a complete demolish and start all over again. And at the same time, you're preserving, as I said earlier, cost and time, at the same time preserving its emotional value. There's also efficient use of existing design. So again, maybe the design that we're working on was so special that we don't want to lose the value of this structure or construction, so we prefer choosing rehabilitation over complete demolishment. While reduced construction time, as I mentioned earlier, time is a very important topic in construction in general because it helps you gain time, get over the project in a shorter period of time. At the same time, gaining money. So these two go side by side, gaining time and gaining money. Also, improved structural performance. So, through rehabilitation, existing steel structures can be upgraded and strengthened to meet modern performances requirements. So, This can include enhancing the load carrying capacity, improving resistance to seismic forces, or incorporating new technologies to enhance functionality. Uh, the methods used in steel rehabilitation. As I mentioned earlier, there's a lot of methods to start a rehabilitation project in steel construction. Uh, so choosing the correct method for that specific structure or building can be a bit challenging. So if we get to know the various methods, we that can help us choose the correct method. Well, I'll start with the first method, which is repair and replacement. So this method involves repairing or replacing individual components of steel structures that have experienced localized damage or deterioration. It may include removing corroded sections, patching welding damages areas, or replacing severe compromised members. As you can see, I gave you the example of the Brooklyn Bridge rehabilitation that was done in New York. So, this bridge underwent a major rehabilitation project to address structural deficiencies. Damaged steel elements such as truss members and suspension cables were repaired or replaced to ensure the bridge's continued structural integrity or functionality. The second method is strengthening, which, like strengthening, depends on adding to the already existing members, not replacing. And this method has a lot of mm, method. We can do strengthening by so many methods. I'll start with the first one, which is adding reinforcements. So additional steel elements such as plates, angles or sections actually can be added to strengthen the existing members. These reinforcements may be bolted, welded, or bonded to the original structure, increasing its capacity to resist to loads. Such as from real life example, I gave you uh, the Brooklyn Battery Tunnel rehabilitation that was done in New York. So this tunnel has underwent a rehabilitation project to strengthen its structural capacity. As part of the project, additional steel reinforcements were added to the walls and the roof, including strengthening those elements. Well, and the reinforcements enhanced the tunnel resistant to potential impacts and increased its load carrying capacity. Third of all, external post tensioning. It is pretty similar to pre-tensioned concrete. It's basically the same thing. It's pre-tensioning with cables. Mostly it's done in like big bridges. I gave you the example of Sydney Harbour Bridge in Australia. So this bridge to accommodate increased traffic loads, because when it was built before, the city of Sydney was not that much crowded. And with the increase of population in Sydney, they needed to increase the capacity of the bridge without having to do a new bridge. Well, sorry. That's why the Sydney Harbour Bridge underwent a strengthening project. External post tensioning was employed, where tension steel cables were added to the bridge's arcs, enhancing its load carrying capacity and reducing deflections. The fiber reinforcement polymer FRP, which is actually there's a lot of researches have been done on FRP because it's the new like trend, we can say. So, FRP composites such as carbon or glass fibers can be wrapped around existing steel members to enhance their strength, stiffness. Well, FRP wrapping is a lightweight and corrosion resistant method that is effective in increasing the flexural and shear capacities of the structure. Uh, the project that had an FRP in its rehabilitation done, uh, an example of the CN Tower rehabilitation that was done in Toronto, Canada. So this tower, which is an iconic steel communication and observation tower, underwent a rehabilitation project to address corrosion and enhance its structural performance. As part of the project, FRP wrapping was used to reinforce the tower steel members such as the main antenna, mast, and the FRP wrapping provided additional strength and durability to the steel structure while maintaining the effects of corrosion. Well, steel plate bonding, we're still in the strengthening method. Well, this technique involves bonding steel plates to the existing members using epoxy adhesives. So, steel plate bonding enhances the strength and stiffness of the structure, can be used for both flexural and shear strengthening. Again, given the example of the St. Louis Getaway Arc renovation, in which was done in Missouri, this piece is a follow-up to an already existing museum in Missouri. So this iconic getaway underwent a major renovation project to address structural issues and enhance its performance. So as part of the rehabilitation, steel plate bonding was used to strengthen the arc steel sections. Steel plates were bonded to the existing members using epoxy adhesives, increasing their strength and rigidity. Next is rehabilitation coatings. Applying specialized coating to the steel structures is a common method actually to combat corrosion and extend to the service life of the construction. As we all know, corrosion is one of the main problems a steel construction can face. So by doing its rehabilitation, it's a must actually in steel constructions. So, given the example of the really famous Golden Gate Bridge in California, specifically San Francisco, so the Golden Gate underwent a rehabilitation works. So, a renewed steel suspension bridge undergoes periodic repainting to protect its steel surface from corrosion. Specialized coatings, including zinc-based primers and epoxy paints, are applied to maintain the bridge's iconic appearance. Corrosion protection, as I mentioned, corrosion is really a big challenge facing steel constructions. So even for normal structures, it is a challenge, and it is a big concern for any engineer working in steel construction, especially with rehabilitating steel constructions, uh, because it like corrosion can be particularly a big problem, especially in harsh environments. Various corrosion protection methods can be employed, including cathodic protection, which involves the use of like impressed current to prevent corrosion. So, additionally, corrosion inhibitors of or rust converts can be applied to mitigate existing corrosion and protect steel surfaces. Given the example of the offshore platform corrosion protection in the North Sea, as you can see, it's literally in the middle of the sea. So these offshores are usually exposed to the really harsh marine environments, making corrosion protection crucial. The corrosion is done in a really short period of time. So in numerous projects, corrosion protection measures such as cathodic protection systems uh, is implemented to these structures. So these measures protect the steel structure from corrosion caused by salt water and other corrosive agents, extending the service life of the platform. Also, one of the strengthening method is upgrading and modernization. So sometimes when you do a rehabilitation to an existing structure, it's not always a problem with the resistance. Sometimes like you want to have the structure have like a new design which goes up with the modern times. So steel rehabilitation includes upgrading to existing structure to meet changing design standards, codes, or functional requirements. Given the example of the London Bridge station redevelopment in the UK, so this bridge underwent a significant modernization and expansion project to improve its capacity and functionality. So the project involved the upgrading and modernization of steel structures, including platforms, canopies, and pedestrian bridges. Uh, Last but not least, monitoring and maintenance. So this is one of the methods for strengthening. Implementing a robust monitoring and maintenance program is essential for the long-term performance of rehabilitated steel structures. This can involve regular inspections, non-destructive testing, and structural health monitoring to detect potential issues. Given the example of the fourth bridge maintenance that was done in Scotland, so this bridge is a historical steel railway bridge, uh, which is regularly monitored and maintained to ensure its structural integrity. Non-destructive testing methods such as ultrasonic inspection and visual inspections are carried out to detect any signs of deterioration or defects in the team members' inability, timely maintenance interventions. Well, before choosing one of the methods that I've mentioned earlier, uh, before choosing a specific method, you have to do a lot of inspection and assessment before really deciding which way you're gonna go with this or any specific structure or construction. So, starting with that, one of the like points that you have to go by before choosing a method is identifying structural deficiencies. So, a comprehensive inspection allows for the identification and evaluation of structural deficiencies in the steel structure or any kind of structure, actually. So this includes identifying areas of corrosion, fatigue, and material degradation, cracking, and other forms of damage deterioration. So through this assessment, uh, it helps to determine the extent and severity of these deficiencies, providing a clear understanding of the structural integrity and performance limitation. Second of all, uh, understanding load and environmental conditions. So by understanding the capacity of that your structure have to indulge and have to tolerate, helps you with which method you're going to go, whether it's FRP or like adding new, like replacing those elements. So it depends on the capacity. Like uh, a bridge that has a lot of people coming by it is not like bridge in a really small village. It's not gonna go. Rehabilitation for those two bridges would not be the same for sure because it depends on the capacity too. Well, at the same time, considering safety and code compliances, so through inspection and assessment, play a vital role in ensuring the safety of the structure and its occupant, sorry, by identifying structural weakness and deficiencies. It becomes possible to address potential safety hazards and non-compliance issues. Determining feasibility and cost effectiveness. So, a detailed assessment enables the evaluation of various rehabilitation options in terms of feasibility, cost effectiveness. It helps to determine whether repair or replacements or strengthening or other methods are suitable for this structure, actually. So, through inspection and assessment, allow for a comprehensive understanding of the project scope, potential challenges, and associated costs. Uh, Determining, feasibility of for long-term performances. So, actually, proper inspection and assessment provide valuable insights into like long-term performance requirements of the structure. So this actually includes considering factors as such as the future anticipated loads. Like right now, it tolerates this amount of loads, but in the future, it may it had to tolerate more. So this is when choosing a method to rehabilitation. This will be taken into consideration. Also, maintenance requirements, like if you choose this method, would maintaining it be possible or not, or would it be costing? So all of these are working methods, working like points, deciding factors actually. So expected service life also is a defining factor. So by conducting through assessment, engineers and project stakeholders can make informed decisions regarding the most appropriate rehabilitation method that will optimize the structure's performance and longevity. Uh, the potential risk associated with working on an existing structure, whether it's steel or concrete, to be honest with this one. When working on an existing structure, it can be very risky for anyone working on site. So because you really, even though we've like read the behavior of the structure, because it's a rehabilitation and it's an already existing structure, sometimes you can't expect everything. You can be faced with a lot of risks. So for people working on site, it can be a bit risky. One of the risks are structural instability. So, because it's an existing structure that needs rehabilitation, it cannot be stable 100%, and you can't really assure be it being stable. Also, falls from heights can be really challenging because when working on really high structures, well, falling can be considered. So everyone should be safe and like paying attention. Also, hazardous materials, because existing structures may contain hazardous materials such as lead-based paint. Asbestos or chemicals. So these can be disturbing or improperly handling these materials during rehabilitation work can lead to health risks for workers, especially for potential environmental contamination. Also, we have electrical hazards. So if you don't pay attention, you will be electrified. This is how much I can say for this one. Also, fire and explosion risks. Certain rehabilitation projects involve hot work operations like welding, for example, cutting or grinding. So, if proper fire prevention measures such as fire-resistant barriers, fire extinguishers, and spark-resistant equipment are not implemented, there is an increased risk of fire explosions. Also, I've talked about hazardous materials. I'll talk about hazardous environments. Sorry. So, working in a confined space or areas with poor ventilation can expose workers to hazardous environments, such as poor air quality or high temperatures or toxic gases. So without proper monitoring and ventilation systems, workers may face health risks, including respiratory problems and asphyxiations. Material handling equipments. So steel constructions in general often require the use of heavy machinery equipments and materials. Uh, so the use of appropriate safety measures can lead to not the good use, sorry, can lead to accidents such as crushing injuries, stuck by accident, or equipment malfunction. The mitigate base to imitate, sorry, to like have mitigate these risks, it is crucial to conduct through assessment, develop comprehensive safety plans, provide adequate training to workers, use proper equipments, obviously, follow applicable regulations and standards, and engage in qualified professionals. So, when having someone work in rehabilitation works, especially in steel construction, these people should have an education about how they are going to work in this environment. Uh, Last but not least, we're going to talk a bit about the future trends and advancements in steel construction rehabilitation world. Uh, well, the field of steel construction is constantly evolving, actually, and several future trends and advancements can be expected. I'm going to talk shortly and briefly about some of the future trends for steel rehabilitation for structures. Starting with advanced non-destructive testing, NDT. Well, non-destructive testing methods such as ultrasonic testing, magnetic particles inspection, and thermography are becoming increasingly advanced. Future advancements in NDT techniques will enable more accurate and increasingly advanced. It will be more efficient in the detection of the problem, if may I say. So for structural defects, corrosion, and also material degradation in steel structures, so allowing for a targeted and effective rehabilitation for these kind of structures. Also, smart monitoring systems, so the integration of sensor technologies and data analytics in steel structures will play a significant role in rehabilitation. Environmental impacts. Well, it has a lot of environmental impacts, so that's how it's helping. Also, there's the 3D printing and additive manufacturing. So, 3D printing and additive manufacturing techniques have the potential to revolutionize the rehabilitation of steel structures because these technologies can be used to fabricate complex, customized, and component replaced parts with high precision and efficiency, of course. So this 3D printing can also enable the integration of sensors and smart materials directly into the steel structure. So if you don't have a piece, a 3D printer can like help you make that like piece or be real, and you can simply add it to the existing structure without having to add a lot of elements, for example. Sustainable rehabilitation solutions. So the focus on sustainability for sure, and environmental responsibility will continue to shape the future of steel rehabilitation. Strengthening and retrofitting techniques. So, new methods for strengthening and retrofitting steel structures will emerge, catering to specific needs and challenges. Innovations may include advanced composite materials like FRP, the one that we talked about earlier, also carbon nanotubes or graphene that offer superior strength to weight ratio and corrosion resistance. Robotic and automated rehabilitation process. So this particular method, it will help us have like an automation that will play a significant role in construction rehabilitation. So enabling safer, of course, and more efficient process. Building information modeling, BIM, integration. So the integration of BIM technology will streamline the entire rehabilitation process. From design and planning to construction and maintenance, BIM enables better collaboration, visualization, and analysis of rehabilitation projects, improving efficiencies and accuracy, actually, communication among stakeholders. Finally, these future trends and advancements in steel rehabilitation construction aim to enhance safety, durability, efficiency, and sustainability by, in general, embracing new technologies and approaches. The industry can deliver more effective and innovative solutions to address the challenges of rehabilitating into existing steel constructions. We got into our conclusion. So, rehabilitation in steel construction can involve restoring, repairing, and upgrading to existing steel buildings for infrastructures for sure. Rehabilitation in steel construction is vital for ensuring the safety, functionality, and longevity of steel structures. Challenges during steel rehabilitation include assessment, compatibility of materials, structural integrity, and safety. So limited access and space constraint, time and cost constraint, and complex in engineering solutions, and lack of documentation. So common methods used in steel rehabilitation include repair and replacement strength line. Through inspection and assessment are crucial before choosing a rehabilitation method, as they help identify structural deficiencies, understand the load environmental conditions, ensure the safety and code compliance, determine feasibility and cost effectiveness. So potential risks are associated with this working on existing structures. This is inevitable, but we can, if the correct measures are being taken, we can assure a safe working environment for workers in general. So in summary, I believe steel rehabilitation is essential for sustainable infrastructures and development, as it promotes resources conservation, reduces environmental impacts, also minimize wastes, improves energy efficiency, of course, also preserves cultural heritage, provides economic benefits, and enhance resilience. So in the end point is, by investing in the rehabilitation of an existing structure, especially steel, communities can achieve their infrastructure goals while minimizing the ecological footprint and contributing to a more sustainable future. And thank you for listening, everyone.
Evet, teşekkür ederiz. Güzel sunum oldu. Şu an arkadaşlardan, katılımcılardan varsa soruları dinleriz. Yoksa da bir ekran kaydı yaparak, yani bir screenshot yaparak, resim olarak bu webinarımızı ölümsüzleştiririz. Yani şu an soruları bekliyoruz. Var mı sevgili katılımcılar? Tamam. O zaman her müsait olan kamerasını açsın. Evet, müsait olan arkadaş varsa ekranını açsın. Ben kamerasını, evet, Gürol Bey var. diğer arkadaşlar da müsaitseler ekranlarını açsınlar ki ben ekran screenshot yapacağım. Evet. Şamil Bey de hazır. Muhammed de hazır. Tamam. 4 kişiyiz. Tamam. Oldu. Müsaadenizle resim çekiyorum. Evet. Haydi bakayım oldu mu? Evet. Gayet güzel. Teşekkür ederiz.
Teşekkürler hocam. Zamanımız için teşekkürler herkese.
Çok teşekkürler. Çok sağ olun. Ağzınıza sağlık.
Teşekkür